Introduction to Embedded Systems and Robotics. When you say that this course is open to all the students, including arts and sciences major, the first question that pops is, do you need any experience in programming? What do I need to know to take this course? And we say that no, you don't have to know much. It's as long as you can think you're ready to explore, you have the right attitude, and that's all we need. And when we come into this class, we start with logical reasoning first. Whatever little problem that you have to solve, how do you think about it methodically? How do you scope the problem? Like, you have to understand the boundaries of any problem before solving it, so that you know that you have solved it completely, right? So simple things from day-to-day things like making coffee. When you're running out of sugar, how do you refill sugar? So you take simple examples like that and you think about the little algorithm or the little protocol or little procedure that you need to solve this little problem. And then from there you write it in English and you see that whether you have completed it, you have sort of addressed all the components of that problem, and then you see that it will work definitely in your case, and then you take it to the programming. When you do things like this, when you think about the logic, you think about how to solve it in a paper, writing the pseudocode or in English, then you can take it to any programming language, right? Once you have the solution, then you can, there's no constraint of what programming language you use. So in our course, we started with the simple C programming. C is a very structured language. Operating systems are written using C. But why we chose C is because we use embedded C in the microcontrollers that we are going to use in the class. We already started the embedded C. After teaching the students the first 5 weeks, we did basics of C. They understood more logic, and whenever they learnt a concept, immediately we gave simple problems based on some simple games like tic-tac-toe, Paramapadam, which is, in Tamil, we call it Paramapadam, which is nothing but snakes and ladders. Is a very ancient Indian game. So taking these as examples, they wrote the pseudocode, understood the logic, and now we will be taking it to the next level of implementing these solutions on the robot. Here is a lab, the robotics lab that we have right now, and you see that I'm holding a little bot here. This is a Firebird 5 robot, an educational platform that we use in this class. And we have lots of other microcontrollers and different accessories that can be used in the sequel of this class. This being the introductory class, we use this Firebird 5. And you will see that this is not just the lab, this is also our classroom. Why we are doing it this way? Because we learn the theory and immediately after that, we implement the solution and understand how that concept is related to the practicals. So theory and practicals go hand in hand in our classrooms. We don't have separate lab sessions. So the lab is combined with the classroom learning. And I think this model is working out beautifully, because even students from arts and sciences major, they find that they can connect immediately. Oh, this is the theory and this is why we have to learn it, and we are doing it practically here. So in Sai University, we want to take this kind of concept where multidisciplinary doesn't mean that you just take courses across different disciplines. You also take the logic, the reasoning across disciplines, so you can solve any problem anywhere in any domain in a very efficient and effective and a holistic way, which are scalable and sustainable.